The James Webb Space Telescope has captured something so chilling that it's left scientists in disbelief. These images show strange lights and shapes in deep space that defy all logic. Could they be signs of something we've never imagined, or something we've always feared? Let us uncover why these terrifying images are the ultimate confirmation of a violent new alien species that wants to conquer Earth. The James Webb Space Telescope was designed to capture light from the farthest reaches of the universe, allowing us to see galaxies and stars as they were billions of years ago. It's the most powerful telescope ever built, and its infrared technology lets it peer through cosmic dust to uncover hidden wonders. Early on, it turned its gaze to the famous pillars of creation in the Eagle Nebula, roughly 7,000 light-years away. Before we dive deeper, it's clear that what the telescope uncovered in the pillars of creation is far more unsettling than anyone anticipated, and it's only the beginning. These massive columns of gas and dust, first photographed by the Hubble telescope in 1995, were given a fresh perspective by Webb. The new images showed stars forming within the pillars, some only a few 100,000 years old. However, these findings also sparked a chilling thought. Could these structures be more than natural formations? Some researchers speculated about artificial origins, igniting debates about extraterrestrial life. Not long after, the telescope aimed at a region known as Pandora's Cluster, a massive area that revealed over 50,000 sources of infrared light. This sprawling mosaic unveiled previously unseen details about the cluster and the galaxies within it. While the image was breathtaking, it also raised concerns. Could the gravitational distortions observed in the area hint at forces or objects we don't yet understand? One of the most perplexing discoveries came when the telescope captured concentric rings surrounding a distant star, W140. The rings were oddly shaped, resembling squares rather than perfect circles. This sparked theories ranging from natural phenomena to possible alien structures. While scientists eventually attributed the pattern to optical artifacts, the discovery highlighted how Webb's capabilities constantly blur the line between the known and the unknown. Another jaw-dropping revelation involved galaxies from the early universe, just a few 100 million years after the Big Bang. These galaxies appeared far larger and more mature than expected, defying current models of cosmic evolution. If they formed so quickly after the universe's birth, what does that say about our understanding of star and galaxy formation? Astronomers are now questioning whether the early universe was far more chaotic and active than previously believed. Some even suggest that these findings might require a complete rewrite of the history of the cosmos. As Webb continued its mission, it turned its focus to the Phantom Galaxy, a near-perfect spiral located about 32 million light-years away. The telescope's infrared sensors revealed a hidden mass of dust and a possible intermediate black hole at the galaxy's center. This finding is particularly intriguing because intermediate black holes are elusive, and their role in galactic evolution remains a hot topic in astronomy. Webb's detailed images provide a new opportunity to study these phenomena, but they also pose difficult questions about the forces shaping galaxies. Closer to home, the telescope captured stunning images of Neptune and its rings for the first time in over 30 years. Like earlier views, Webb's infrared imaging revealed fine details of the planet's thin, dusty rings and high-altitude clouds. These images not only enhance our understanding of Neptune, but also hint at dynamic processes in its atmosphere. For instance, a bright band of light encircling Neptune's equator suggests powerful atmospheric currents. Additionally, Webb detected 7 of Neptune's moons, including Triton, which reflected a dazzling 70% of the sunlight hitting its surface. These findings remind us that even in our solar system, questions abound. The telescope also took an unprecedented look at the Tarantula Nebula, a massive star-forming region 161,000 light-years away. Hundreds of newborn stars, previously hidden by cosmic dust, were revealed in Webb's images. This discovery not only provides insight into how stars are born, but also offers a glimpse into the conditions of the early universe. The nebula's intricate web of gas and dust earned it its nickname, as it resembles the silk-lined burrow of a tarantula. Such findings highlight the telescope's unmatched ability to capture the raw beauty and complexity of space. After finding new details about stars and galaxies, the telescope looked closer to home, where planets and moons may hold surprising clues about life. One of Webb's most captivating discoveries involves Titan, Saturn's largest moon. With its thick atmosphere, liquid methane seas, and Earth-like landscapes, Titan has long been a subject of fascination. Webb's observations revealed bright patches on Titan's surface, likely methane clouds, and mapped the distribution of gases in its atmosphere. These findings could help scientists better understand how atmospheres evolve on planets and moons, providing clues about the potential for life beyond Earth. The telescope's ability to peer through Titan's dense haze marks a significant leap forward in planetary science. The James Webb Space Telescope has already revolutionized our understanding of the universe in its first 2 years of operation. From uncovering the origins of galaxies to exploring the dynamics of planets and moons in our solar system, its discoveries have challenged long-held beliefs and opened new avenues of inquiry. Yet, these breakthroughs come with a sense of unease. The more we learn about the universe, the more questions arise. What other cosmic phenomena might Webb uncover that could fundamentally alter our perception of reality? As the telescope continues its mission, scientists are planning even more ambitious observations. Webb's unparalleled capabilities make it the perfect tool for probing the universe's deepest questions. From studying the atmospheres of exoplanets to investigating the conditions of the early cosmos, the telescope promises to push the boundaries of human knowledge. Each new discovery brings us closer to understanding the universe's complexities, but it also reminds us of the vast unknown that lies beyond. The James Webb Space Telescope is not just a marvel of engineering. It is a window into the cosmos. Its images inspire wonder and curiosity, urging us to question what we know and seek answers to the question of existence. As Webb continues to explore, it holds the potential to reveal the universe in ways we can only begin to imagine. We can't yet imagine forever changing our understanding of the cosmos and our place within it. The telescope's discoveries amaze us, but they also bring big questions about things in space we still don't understand. What really happens inside black holes? Let's face it, the universe is a weird, mind-blowing place, and no matter how much we think we've got it figured out, the truth is we're barely scratching the surface. With all the fancy telescopes, equations, and brainy scientists throwing out theories, there are still countless questions that leave us scratching our heads. What really kicked it all off? What's out there lurking in the dark corners of space? And why does everything seem to work the way it does, or not? The Big Bang is supposed to be the grand kickoff to all of this. Around 13.8 billion years ago, the universe exploded into being from a single, unimaginably dense point. But here's the kicker. What was there before the Big Bang? Was it just a whole lot of nothing? Or was there something weirder going on, like another universe collapsing in on itself, or some infinite loop of universes rebooting over and over? And if the Big Bang was the start, why did it happen at all? For all we know, it could be the cosmic equivalent of flipping a light switch, but nobody knows who or what flipped it. Now here's the part that'll really mess with your head. Everything we can see, planets, stars, galaxies, you name it, makes up just 5% of the universe. The rest? It's mostly made of two invisible things, dark matter and dark energy. Dark matter, which makes up about 27%, doesn't shine, reflect, or absorb light. It's like the universe's ghost, and the only reason we know it's there is because it's holding galaxies together with its gravity. But what is it actually made of? Tiny particles nobody's discovered yet? Something completely beyond our comprehension? As for dark energy, the remaining 68%, it's even stranger. It's basically the force pushing the universe to expand faster and faster, but nobody has a clue why it's doing that or how it works. Black holes are the ultimate cosmic no-go zones. Get too close, and you're done. These things have gravity so strong they swallow light itself, so whatever falls in can never come back out. But here's the question. What happens inside them? Do they crunch everything down to a single point, a singularity, where all the laws of physics just break? Or is there some kind of wormhole action going on, spitting matter into another part of the universe or even another universe? And then there's the information paradox, which says that the stuff black holes eat isn't destroyed, but nobody knows where it ends up. Could the answers be lurking at the event horizon, the edge of no return? The Fermi paradox is the ultimate cosmic ghost story. With billions of galaxies, each full of stars and planets, The odds are there's got to be other life out there. Yet where is everyone? No radio signals, no spaceships, no little green men saying hello. Some say intelligent life is just super rare. Or maybe advanced civilizations don't want to talk to us. Or, scarier still, they're already here watching us, and we're too clueless to notice. Whatever the case, every time we point a telescope at the stars, the silence gets a little louder. For every particle of matter, there should have been an equal amount of antimatter at the Big Bang. When matter and antimatter meet, they cancel each other out in a burst of energy. So why is there so much matter left and barely any antimatter? Did the universe rig the game so matter would win? Scientists are still trying to figure out what tipped the balance, but so far, the scoreboard is all matter, no antimatter. Neutrinos are like the ninjas of the particle world. They're everywhere. Trillions pass through your body every second, but they barely interact with anything, making them insanely hard to study. We know they have mass, but it's ridiculously tiny, and nobody's sure how much. Could neutrinos hold the key to understanding how the universe works on the tiniest scales? Some even think they could solve the matter-antimatter problem. For something so small, they've got big implications. Remember when we thought the universe's expansion would slow down over time? Nope. Turns out it's speeding up, thanks to dark energy. But here's the kicker. We can't agree on how fast it's expanding. Different methods of measuring give slightly different answers, a problem called the Hubble tension. If we can't figure this out, we might be missing something huge about how the universe works. The multiverse hypothesis suggests that our universe might be one of countless others. Think of it like bubbles in a cosmic foam, each bubble a separate universe with its own rules and realities. If this is true, it's both mind-blowing and deeply frustrating because we have no way of proving it. Are there universes where time runs backward, or where the laws of physics are completely alien to us? The possibilities are endless, but right now, it's all just wild speculation. Time is something we all experience, but nobody really knows what it is. Did it start at the Big Bang, or has it always existed? Will it ever stop? And why does time seem to flow in one direction, even though the laws of physics say it could go either way? These are questions that go beyond science, delving into philosophy and even our understanding of existence itself. The cosmic microwave background, CMB, is like a baby picture of the universe, showing us what it looked like shortly after the Big Bang. But not everything about the CMB adds up. There are tiny anomalies, temperature fluctuations that don't fit our models of how the universe should have evolved. Could these be hints of new physics, or are we just not looking at the data the right way? Physicists have been chasing a dream for decades, a single theory that explains everything. Right now, we've got quantum mechanics for the small stuff and general relativity for the big stuff, but they don't play nicely together. Combining them into a theory of quantum gravity would be the holy grail of physics, but it's proving to be one of the toughest nuts to crack. The universe is not just a massive gathering of stars, planets, and galaxies. Between these glowing clusters lie enormous empty spaces known as cosmic voids. These areas are unimaginably vast and seem almost completely empty, yet they play an important role in how matter and energy spread out across the universe. Scientists wonder how these voids came to exist. Are they simply accidental gaps in the cosmic web, or could they be key to understanding forces like dark matter and dark energy? The biggest question is what will happen to the universe in the end. Will it continue to stretch and expand forever? If so, the stars will eventually burn out, leaving a cold, dark expanse, a bleak fate scientists call heat death. This idea suggests that one day all the light and warmth in the universe will fade, and only emptiness will remain. Another possibility is the Big Crunch. In this scenario, the universe might stop expanding and start collapsing inward. All the galaxies and stars could rush back together into an incredibly dense state, possibly leading to another explosion like the Big Bang. But no one knows for sure if this dramatic collapse will happen or when it could occur.